Okay. So we have seen OS module, right? And then OS module. So after this, what you have is multi-threading or multi-tasking, right? So multi-threading or multitasking applications. So when you're talking about types of applications, so actually there are two types of applications. One is single tasking applications, and one more is multitask applications. There are two types of applications. One is single task, and one more is what here? Multitask. So what is a single task applications is an application which allows performing only one operation is called a single task applications. An application which allows performing only one operation, that is called a single task applications. Example is DOS. Means until you do one operation, you cannot do any other operation. Until you do one operation, you cannot do any other operation. That is called single tasking. Okay, if one operation is in running, you cannot run any other operation. Until you close that operation, you cannot do any other operation. That you call it as which one? Single task. For example, if you see old mobiles, in old mobiles, if you open one application, until you close that application, you cannot open any other application. So that is what single tasking, which allows to perform only one operation. So example is DOS operating system. So there is one more type of applications which is called multitasking applications. An application which allows performing more than one task. An application which allows performing more than one task concurrently or simultaneously is called multitasking applications. An application which allows performing more than one task concurrently or what? Simultaneously is called multitasking applications. So where you can perform more than one operation simultaneously or what? Concurrently. Because one processor can do only one operation. But if you want more than one operation should be done, that is done concurrently or what? Simultaneously. So these multitasking applications are two types. One is process-based multitasking and one more is what? Thread-based. How many types of multitasking applications? Two types. Process-based multitasking is there and one more is thread-based multitasking. So what is a process here? What is a process? A process is nothing but instance of a program. What is a process here is instance of a program or a program under execution. So simultaneous execution of more than one program is called a process-based multitasking. Simultaneous execution of more than one program simultaneous execution of more than one program is called a process-based multitasking. Okay, simultaneous execution of more than one program is called process-based multitasking. And this multitasking is used for developing which one? Operating systems. So generally, if you work with operating system like Windows, if you take Windows, I'll open Notepad. When I open Notepad, what will happen? It will create one process called Notepad. If I open Notepad, it will create one process called which one? Notepad. So when Notepad is in running, so suppose Notepad is open. I want to open Paint. Okay, Notepad is already open. Means Notepad program is running. Now I want to open Paint. To open the Paint, I don't require to close what? Notepad. When Notepad isn't running, I can open which one? Paint. When Notepad isn't running, I can able to open what? Paint. So when Paint is running, okay, I can able to open what? MS Word. It means when Notepad is open, I'm not doing anything on Notepad. If I'm not doing anything on Notepad, it means processor is idle. Your CPU is what? Idle. I'm utilizing that idle time to execute what? Another program. So I open the Paint. Then when Paint is running, I'm not doing anything on Paint. It means processor is what here? Idle. Then I'm utilizing that idle time to run another program. To run another program. What is that another program here? MS Word. So here simultaneously you are executing how many programs? More than one program concurrently. Simultaneously or what? Concurrently. Not at a time. You cannot work at a time on Notepad, Paint and MS Word. At a time you can work on only one program, but simultaneously you can work on more than one program. I can work on Notepad while I can switch from Notepad to what? Paint. From Paint to I can switch to what? MS Word. From MS Word I can switch to what? Paint. Now it means you are utilizing the CPU idle time. The advantage of multitasking applications is utilizing the CPU idle time. You are utilizing the CPU idle time to execute another program. You are utilizing the CPU idle time to execute what? Another program. So that kind of thing is called which one? Process-based multitasking. So what is a process is an instance of a program and simultaneous execution of more than one program. More than one simultaneous. One processor can do at a time only one job, but simultaneously it can do more than one job. One processor at a time it can do only one job. Simultaneously it can do more than one job. So that you call it as multitasking. Task is nothing but operation. Task is nothing but operation. Task is nothing but a job which is performed by what? Microprocessor. Okay, a job which is performed by your application, that you call it as process based. Generally process based multitasking is used for developing which one? Operating systems. Not at application level. This is used at which level? Operating system level. Like Windows is there. Windows is what? Multitasking operating system. Okay, like Linux is there. Linux is what? Multitasking operating system. Okay, Solaris, Android, your mobile is there. It's a multitasking. You open one program. You can switch to what? Another program and you can run it. But at a time you can work only on one program. But simultaneously you can work on more than one program. But this type of multitasking is suitable for developing which one? Operating systems. But I want to develop a program which can perform more than one operation. I want to develop one program, and that program should perform more than one operation simultaneously or concurrently. What is the advantage of multitasking is utilizing the CPU idle time. For example, in application development, what will happen is, suppose if you are working with, suppose I develop one, okay, I develop one application where okay, suppose I develop one application where you have two things. One is upload. There are two things out there. One is upload. This is upload, and there's one more which is called as download. So my program is having two functions. One is upload function, and one more is what? Download function. If I click on upload, it will call which function? Upload function. But until execution of upload function is not completed, if it is single tasking, until execution of upload is not completed, I cannot click on which one? Download. Now this is multitasking or single tasking? Single task. Single task. Because until execution of one function is not completed, I cannot execute what? Another function. Until execution of one function is not completed, I cannot execute another function. But when uploading is going on, I want to perform simultaneously which one? Download also. Then I want this both the functions to be run what? I want this both the functions to be run what? Concurrently. Concurrently or what? Simultaneously. Concurrently or simultaneously. It is like this. Suppose one person at a time we can do only one course. Okay, suppose at a time is suppose 7:30 you can attend Python course. At 7:30 you can do only Python course. But simultaneously can do what? More than one course. 7:30 you can do Python. 9 o'clock Django. Okay, 11 o'clock data science, like this. But is having only 1 month. Within 1 month time, is doing how many courses here? 3 courses. Simultaneously. Now it means is trying to schedule it, right? Is scheduling. This is Python course. This is Django course, and this is what? Data science course. It means what is doing it is utilizing his idle time. Is utilizing his idle time to do what? Multiple courses. Multiple courses. So every program will have the input, process, and output. So one processor is there. Okay, when I click on upload means I should read the data and send the data to somewhere. So suppose it read the data and sending means, okay, your processor will be idle. So in that case, it will try to perform which operation? Downloading. Click on it. So every program will have the input as well as output. So in that case, until the user is not given input, your processor is what? Idle. Now, to utilize that idle time, I'm trying to develop which applications here? Multitasking applications. So by default, your application is not multitasking. By default, your application is single tasking application. By default, now suppose I write some functions here. There is a function 1. Inside function 1, there is a function 2. Inside function 2, I write another function 3. And inside function 3, okay, there is a function main and called function 1, function 2, and called even which one? Function 3. I called function 1, I called function 2, I called which one here? Function 3. How many functions I called here? 3 functions I called. So what will happen? Now program execution starts from where? Main. This is one executable statement. My program execution starts from main. This is one executable statement. Executable statement. Okay, this is an executable statement. Okay, right now this is executable statement. Executable statement. So the execution starts from where here? Main. And this main calls which function? Function 1. Okay, this main calls function 1. And after execution of function 1, okay, until execution of function 1, after executing function 1, the control will return to which function? Main, because this is called as calling function and this is a called function. So whenever function is called, the control is switched from calling function to called function. And after executing this function, return to which function again? Calling function. Then is it execution of this function is completed or not? Yes. Then call which function again? Function 2. So the control is moved to which function? Function 2. And after execution of this function 2, what will happen? The control is returned to which function? Main function. And after execution of this function 2, now execution of function 2 is completed. Then it will call which function? Function 3. It means in this example, until execution of function 1 is not completed, it will not do which one? Function 2. Until execution of function 2 is not completed, it will not execute what? Function 3. Until execution of function 1 is not completed, it will not execute function 2. Until execution of function 2 is not completed, it will not execute what here? Function 3. Means how many functions it is executing at a time? Only one. But I don't want all these functions to be run. So it means default flow of execution is sequential. First function 1, then function 2, and then what? Function 3. First function 1, second function 2, and third is what? Function 3. But I want all these functions to be executed how? Simultaneously. I don't want the function 2 should depend on what? Function 1. I don't want function 3 should depend on what? Function 2. All these functions I want to execute simultaneously. Then you put these functions, you put these functions, all these functions, you execute independently or individually. All these functions you execute independently or individually by writing inside one thread. You write all these functions, you execute all these functions individually or independently by writing inside one thread. So thread doesn't depends on a thread executed independently or individually. So one thread doesn't depends on which one? Another thread. So threads get executed how? Individually. Threads get executed what? Individually. One thread doesn't depends on what? Another thread. Thread. Why you are writing a thread? To perform operation. Why you are writing a thread? To perform operation. Why you are writing a thread? To perform operation independent of what? Other operations. Okay. Suppose I run thread 1. I run thread 1. I run thread 2. I run what here? Thread 3. But thread 2 depends on thread 1? No. Thread 1 is executed separately. Thread 2 executed separately. And thread 3 executed what? Separately. So it means all these threads are executed individually or not? Yes. So one operation doesn't depends on what? Another operation. It means all these operations are executed simultaneously or not? Yes. Okay, simultaneously. These are executed how? Simultaneous. Now I write download. There is a function called download. There is a function called what here? Upload. Download is one thread. Upload is what here? Another thread. If I click on download, download will be executed separately. If I click on upload, upload will be executed separately. And this both will be executed how? Concurrently or what? Simultaneously. But if I don't put in a thread, if I call function 1, it will call function 1. After executing function 1, it will call which one? Function 2. After executing function 2, it will call which one? Function 3. Means at a time it is doing how many operations? Only one. Until execution of function 1 is not completed, it will not call the function 2. Until execution of function 2 is not completed, it will not call the function 3. Means one functionality depends. So to avoid that, okay, to avoid that, you are trying to use multitasking. thread-based thread-based multitasking. So what is a thread is? A thread is an independent part of execution. What is a thread is? A thread is an independent part of execution within program. A thread is an independent part of execution within program. A thread is an independent part of execution within program. Okay. Thread performs operation independent of what? Other operations. Now, simultaneous execution of more than one thread is called thread-based multitasking. Why you are writing a thread? You are writing a thread. You are writing a thread to perform operation, but that operation should be independent of what here? Other operations. Thread is independent part of execution within program. Simultaneous execution of more than one thread is called which one? Thread-based multitasking. Thread-based multitasking. Thread-based multitasking is suitable. Thread-based multitasking is suitable. Thread-based multitasking is used at which level here? Application level. Okay. Now, advantage of multitasking applications are utilizing CPU resources or CPU what? Idle time. Utilizing the CPU resources or utilizing the CPU idle time, right? So thread-based multitasking is used at application level. Advantage of multitasking applications are utilizing the CPU resources or CPU idle time. But how you develop this multitasking, thread-based multitasking for that? So it is provided one module called which one? Threading module. Provides classes and functions for developing which applications? Multi-threaded applications. Okay. So threading module provide classes and functions for developing multi-threaded applications. So now whenever you are talking about multi-threading, so there will be a thread scheduling will be done. Okay, scheduling means which thread to be, how threads will be executed, that is done by thread scheduler, and that thread scheduler is provided by whom? Python virtual machine. So Python virtual machine is having thread scheduler that will schedule the execution of which one? Threads. There are two types of schedulings you'll have. One is preemptive and one more is what? Non-preemptive. That depends on which one? OS. What will happen in preemptive scheduling is, for example, if we take Windows, for example, there are two threads or three threads are there. So there is a thread 1, there is a thread 2, and there is a thread 3. So what your operating system will do is, operating system, this is operating system, and this is Python virtual machine, and this is your processor, which is called as CPU. Now PVM is having what here? Thread scheduler. Now this thread scheduler allocates some time. Suppose it is given 1 millisecond for this particular thread. Okay. So what will happen within this 1 millisecond? 1 millisecond it will process this thread, execute this thread, and then after that, this thread scheduler may schedule another thread, giving some time for this thread. And within 1 millisecond, this particular thread will be 1 millisecond, it will process this particular thread. And assume that after that, again it is scheduled, which one here? Thread 1, giving 1 millisecond. Again, it will process the execution of which one? Thread. It means what will happen here? It is trying to execute this both the threads. How it is executing? Simultaneously by allocating some time. By allocating some time. This you call it as which one? Time slicing. Now most of the operating systems support which one? Time slicing. Some time is given to each thread. Within that time, it will execute the thread. Within that time, it execute the thread, and then suppose it is given 1 millisecond. In 1 millisecond, if it is not completed, then again it will schedule the execution of what? Same thread. And then what will happen? It will process the execution of that thread and switch to what here? Another thread. Now, there will be a context switching between one thread and what here? Another thread. But thread scheduling is done by whom? Python virtual machine. Thread scheduling is done by Python virtual machine, but there are different scheduling algorithms out there. One is preemptive scheduling and one more is what? Non-preemptive. The same thing, like just now I said, one person want to do multiple courses like Python, Django, okay, and want to do data science. Now person will schedule, okay. Now this is 7 to 9 this course, okay, 9 to 11 this course, 11 to 1 this course. Now he'll move simultaneously, is trying to do how many courses here? In the same way. So this is a thread 1, thread 2 and thread. Now who is the scheduler here? Python virtual machine. So 1 millisecond is given to this, 1 millisecond is given to this, 1 millisecond is given to this. So it will execute this for 1 millisecond and switch to what? Another thread. Execute this for 1 millisecond and go to what? Another thread. After executing this, it will come back to which one? First thread, and again allocate some time and execute it. Again switch to. Now there will be a context switching between one thread and what? Another thread. So this is how it will try to execute it, but that simultaneous execution is done by scheduling it, and that is completely provided by which one? Thread scheduler provided by Python virtual. Thread scheduler provided by Python virtual machine. Thread scheduler provided by Python virtual machine. Thread scheduler provided by Python virtual machine, right? Yes. Then how to create a thread? Why you are creating a thread? To perform some operation, right? So how to create a thread? You can create a thread in two ways. One is by inheriting thread class. Second one is by using callable object. Okay, one is by inheriting thread class, and second one is by using which object? Callable object. By inheriting thread class by using callable object. So what you're doing in using callable object is, now in this approach, we create a thread object by defining target. So target is a function which is executed by whom? Thread. In this approach, we create a thread object by creating or by defining what here? Target. So target is a function which is executed by whom? Thread. For example, now if you see this application, simple program. If you see this simple program here, so there are two functions. Okay, there are two functions are there. What is the first function? Even function. And this even number function generates which numbers? Even numbers. There is an odd function, and this odd function will generate which numbers? Odd numbers. Even function will generate even numbers. Odd function will generate what? Odd numbers. So first I call which function? Even function. Then I call which function? Odd function. Okay, first I call even function, and then I call which function? Odd function. So if I run this, what happened first? Executed which function? Even function, and then called which function? Odd. Executed first even function. Okay, which function is called first? Even function is called first. Even function is called, and this even function is generated all even numbers. Even function is generated all even numbers. And after execution of even numbers, the control is returned to which function? Main. And then called which function here? Odd function. And this odd function will generate all which numbers? odd numbers. But is it single tasking or multitasking? Single task. After executing even only, it is executing which one? Odd, sequential. First it is doing even numbers and then it is doing which one? Odd numbers. First even numbers, then it is doing odd numbers. But I want this even and odd should be executed individually. Then what I'm doing, I'm creating a thread saying threading dot thread. So I create a thread and this thread should perform operation, right? So what is the target for this thread is even. Now T2 equal to threading dot T2 equal to threading dot thread. And what is the target for this particular thread is odd numbers. Now this thread will call which function? Even function. Okay, this thread will call which function? Even function. And this thread will call which function? Odd function. This thread will call which function? Even function. This thread will call which function? Odd function. How can you execute a thread? By using a start function. T1 dot start and T2 dot what? Start. So when I say start, this both the threads are given to what? Scheduler. And who will schedule the execution of threads? Thread scheduler. So how can you run the threads? By calling which method here? Start method. Okay. Now I try to execute this at the command prompt because here you cannot see the output properly. It's doing simultaneously only, but you cannot see the output properly. So what will I do is I just go to command prompt. So where is my program in? Okay, this is my folder. So test. So now you can see first which one is executed? Even numbers. So within given time, a thread is generated how many even numbers? Two even numbers. And after that switch to which one? Odd thread. So after generating even numbers, within given time, it is generated how many even numbers? Two even numbers. After generating two even numbers, then control is switched to which thread? Odd thread. And after generating odd number, so within a given time, odd thread is generated how many odd numbers? Only one. Then within that, again, it is switched to which thread again? Even thread. But within given time for even thread, how many generated? Two even numbers. Then after that, it is switched to which thread here? Odd thread. And within given time, it is generated how many odd numbers? Two odd numbers. And then switch to which thread again? Even thread. But within given time, it is generated one. So simultaneously. So is it this both are executing simultaneously or not? Yes. Now simultaneous execution of more than one thread. Simultaneous execution of more than one thread, which you call it as thread based. It is called as which one? Thread based. It is called as a thread based multitasking. It is called as thread based multitasking. Thread based. A thread is an operation executed independent of other operations, and simultaneous execution of multiple threads is called as which threading? Thread based multitasking. Thread based. So in this case, no, but output will not be the same. Output will not be the same. Output will not be the same. Okay, output will not be the same. Output will not be the same because this output might be various from one execution to what? Another execution. Now, if I run this, I may not get the same output because the execution of the threads is completely depends on Okay, right now there will be a simultaneous execution, right? So there will be a simultaneous execution between the threads, right? So that, yes. This is one example here. For example, yes. So this is creating a thread by using which object? First approach by using which object here? Callable object. What you are doing in callable object? You are creating a thread. Thread is a class here. You are creating object of which class? Thread class. And for this object, which one is a target? Even. So this thread will execute which function? Even function. This thread will execute which function? Odd function. But how you execute a thread? By calling which function? Start. So when I say start, this both the threads are given to what? Scheduler. And scheduler will schedule the execution of what? Threads. Scheduler will schedule the execution of what? Threads. So you are saying T1 dot start and T2 dot what again? Start. Okay. Now this is creating a thread by using which object here? Callable object. But there is another way of creating a thread. What is it another way? There is another way of creating a thread. What is it another way? By inheriting which class? Thread class. There is another way of creating a thread. What is it another way? By inheriting which class? Thread class. Inheriting a thread class. So creating a thread by inheriting which class? Thread class. Now we can create a thread by inheriting which class here? Thread class. So the class which inherits thread class must be override, must override which method here? Run method. So whichever class inherits thread class, whichever class inherits thread class must override. Whichever class inherits thread class must override. Whichever class is inheriting, that class must override one method. What is that method? It should override run method. It means here in this approach, you're writing functions separately, and then you are creating thread object and sending that function. You are writing functions separately. You are creating a thread object and you are sending that function. It means functionality is different. Functionality of thread is separated from thread. Okay. If any changes in functionality, I do changes in what? Functionality. So maintaining your application becomes easier. But what will happen in inheriting thread class? You directly say class, thread class name, and inherit which class? Thread class. So thread class inherits the properties of which class? Thread class. After inheriting, now this thread class is having one function or method called which one? Run. So you have to override run method of which class? Thread class. Because the operation of a thread, you'll write inside which method? A run method. You write the operation of a thread inside which method? Run method. Logic or operation performed by what? Thread. Whatever operation performed by thread, you have to write in which method here? A run method. So definition, what is the name of the method? Run. So the logic or operation performed by what? Thread. So that you are writing in which method? A run method. For example, again, now compare with the previous example. I'm creating which thread here? Even thread. But in this example, we created which function? Even function. Odd function, and this both functions are sent to which object? Thread object. But here we are directly developing which class? Even thread class. And even thread class inherit which class? Thread class. Even thread class inherit which class here? Thread class. Even thread class inherits which class here? Thread class. And then there is a init method, and this init method calls the init method of which one? Super class, because to inherit the properties of which class? Thread class. And where you are writing the operation of a thread inside which method? Run method. What event thread is doing? Event thread is doing some operation, right? Where you are writing the operation of that thread inside which method? Run method. Run method. After inheriting, you are writing the operation of a thread in which method? Run method. So what this run method is doing? It is generating which numbers? Even numbers. So where you are writing the logic of a thread? You are writing the logic of a thread in one object level method called which one? Run. So whenever you execute a thread, your thread is executed by calling which method? Run method. So whatever operation performed by the thread, you should write inside which method? Run method. So this is the even thread. Now even thread generates which numbers? Even numbers. And there is one more thread. What is it? Another thread here? Odd thread. So odd thread is inherited which class? Thread class. Odd thread is a thread. Even thread is a thread. Odd thread is a thread. And override. Which method? Run method. And you write a logic here. You write a logic here for generating which numbers? Odd numbers. You write a logic here for generating which numbers? Odd numbers. You write a logic here. You write a logic here to generate which numbers? Odd numbers. So one is even numbers. Okay, one is even numbers. And one more is which numbers? Odd numbers. Okay, one is even numbers. And one more is which one here? Odd numbers. Okay, so these are two different classes. Now, tomorrow, right? So those are online. Online students. Tomorrow I said you'll have a class from 8 to like 10:30 or 11. Okay. Now you have to join with this link. This is a special link, right? Okay, you have to join with this link. So this is a Zoom link here. Morning 8 o'clock. Okay, this is a link. So this is a Zoom ID. And this is a password here. So you'll have one special class on NumPy Pandas. Okay. Tomorrow I'll be taking tomorrow and day after. Okay. So this is the Zoom ID 956. Okay, 8. Tomorrow you'll have the class. Okay, tomorrow you'll have the class from 8 to 11. Okay, I'll take NumPy and one more is Pandas. You'll have the class from 8 to 11. So tomorrow and Saturday as well as on Sunday. 2 days you'll have. Same link you have to use it. And Sunday you'll have only online, no offline. Okay. Sunday you have to attend only online. You people should attend only online. Take this link. Okay. Sunday you have to attend only online. So you have to take this link, you have to join. Okay. Sunday you don't have offline. Sunday you'll have only online. Take this link. No use. If you are using data science, then only you'll use NumPy pandas. Otherwise, there is no use of NumPy pandas. Only for data science people, this is useful. But if you are going for web development, this is nowhere use. Okay. Only data science people, this NumPy pandas is useful. Other people, there is no use of NumPy pandas. Okay. But maybe some interviews they may ask, NumPy pandas. For that reason, you have to learn NumPy pandas. Some interviews they may ask, NumPy pandas. For that reason, you have to learn like NumPy pandas. So there is a event thread, and there is one more which is called as which one? Odd thread. Two threads. So here two threads are created here. One is for generating even numbers. One is for generating what here? Odd numbers. So that is called as even thread. And one more is which one? Odd thread. So created object of even thread and created object of which one? Odd thread. So T1 equal to even thread and T2 equal to which one? Odd thread. So here, see the previous approach and this approach, we write functionality and we send it to thread here. But here we write directly functionality inside which class? Thread class. So we created event thread object and we created which object? Odd thread object, because event thread is a thread only and odd thread is a thread only, right? Then I said T1 dot start and T2 dot start. So this is one more way of creating a thread. This is another way of creating a thread. So different approaches you have. So this is one more approach of creating what? Thread. This is one more approach of creating thread. Now you can see again. So scheduling, see the scheduling now. First scheduler is scheduled which thread here? Event thread. So within that time, how many even numbers are generated? Only 2. Then scheduled which one? Odd thread. And within given time, it generated how many odd numbers? Only 2. Again, given time for which thread? Even thread. But within this given time, how many numbers generated? 6 to 20. All generated. Then switch to which thread here? Odd thread. Okay, once the execution of thread is completed, then it will stop. But there will be a switching or not, context switching between one thread toward another thread simultaneously. It is just like this. For example, if you are working like there is a reservation server is there. Some reservation server. So there will be multiple clients. There will be multiple passengers who send a request. There will be multiple passengers who send a request, right? There will be multiple passengers who send a request to, there will be multiple passengers who send a request to what? Reservation server. There will be multiple passengers who send a request to what? Reservation server. Multiple passengers who send a request to reservation server. Okay. So now one passenger will not wait. There's a passenger one, there's a passenger two, there is a passenger three. Then how reservation server should reserve the tickets, right? But how it will reserve the tickets? It will reserve the tickets for these passengers how simultaneously. Means it will create what here? Thread. It means one passenger will not wait for another passenger. Reservation is what? Completed, right? Now I should do it how? Simultaneously. It should do it how? Simultaneously. Simultaneously. Suppose, okay, assume that this is, now if you take this example itself, suppose this is one program, one server called math server. What is a server here? Mathematical server. So there is a multiple clients. Client 1 is there, client 2 is there, client 3 is there. Now mathematical server generate even numbers. Mathematical server generate which numbers? Odd numbers. So client 1 send a request, client 2 send a request, client 3 send a request. So client 1 want to generate even numbers. Client 2 want to generate odd numbers. Client 3 want to generate which numbers? Even numbers. Then what your server will do, it will create a thread object. It will create, for generating even numbers, it will create which object? Even thread object. For generating odd numbers, it will create which object? Odd thread object. For generating even numbers, it will generate again which object? Even thread object. Now for all these clients, all these clients, it will generate even odd. How? Concurrently. Means this client will not wait until execution of what? Another client. All these clients, it should give the result how? Simultaneously. Then you go for which applications? Multi-threading applications. Multi-threading applications. Okay. Now you can see this is concurrent. This is concurrent, right? If you see the life cycle of a thread, if you see the life cycle of a thread, now thread is having different states. Okay, thread is having different states here. Thread is having different states. Thread is having different states. Okay, thread is having different states. The first one is called as a newborn state. What is the first one? Newborn state. And second one is runnable state. Third one is running state. Fourth one is idle state. Fifth one is what here? Dead state. So newborn state, runnable state, running state, idle state. And one more is what here? Dead state. Newborn state, runnable state, running state, ideal state, and one more is what here? Dead state. So whenever you create a thread is in which state? Newborn state. Now just create a thread. But once you call the start, how you execute a thread? By calling which function? Start function. How you execute a thread? By calling which function? Start. So once you call the start function, okay, once you call the start function, a thread is moved from newborn state to which one? Runnable state. Runnable means this thread is given to what? Scheduler. Who will schedule the execution of thread? Thread scheduler. Once it is scheduled, then it is moved to which state? Running state. Once it is scheduled, then it is moved to which state? Running state. Who is doing all this? By thread scheduler provided by Python virtual machine. So it is moved to which state here? Running state. Once the execution of thread is completed, it is moved to which state? Dead state. Once the execution of thread is completed, then it is moved to which state? Dead state. But sometimes the running thread can be interrupted. Now you can interrupt the execution of thread. So when you interrupt the execution of thread, a thread might be moved into which state? When you interrupt the execution of thread, a thread might be moved into which state? A thread might be moved into which state? Okay, idle state. Idle state. Once it is resumed back, once it is resumed back, again it is moved to which state? Runnable state. Okay, right? So this is a life cycle of a thread. So once the execution of thread is completed, then it will move into which state? Dead state. But once the execution of thread is done, you cannot start again. Once the thread is dead, you cannot start what? Again, right? Now this is how, now suppose if you take this is one application, right? So what is this here? Alpha server is there. What is the server here? Alpha server. What is the job of alpha server? Generating alphabets. So there will be multiple people who send a request to what? Alpha server. But your alpha server should generate alphabets for all these people. But how we should generate? Simultaneously. So for client 1, it should generate some alphabets and go to which one? Client 2. Generate some alphabets and go to which one? Client 3. Generate some alphabets and go to which one? Client 1. Generate some alphabets and come back to which one? Client 2. So simultaneous. So for that, alpha server is using which one? Alpha thread. For that, alpha server is using which one? Alpha thread. So whenever clients send a request, right, now your server is creating threads of which type? Alpha thread, right? So every thread object, whenever you create a thread object, your thread object is created with some attributes. Every thread is having name as well as what? ID. So duplicate names can have, but duplicate IDs are not allowed. Name is nothing but string. String used for identification purpose only. It has no semantics. No, there is no rules for this. So multiple threads may given the same name. So the initial name is set by the constructor like thread 1, thread 2, thread 3. So by default, when you create a thread, every thread is given some name and whose name starts with thread 1, thread 2, thread 3 like that. But how can I get the name of the thread? By using get name. So this will return the name of the thread. Now, if you see this alpha server, this is, suppose this is which one here? Alpha thread. Who's using alpha thread? Alpha server. Now, whenever client send a request, it is creating what here? Threads. Of which type? Alpha thread. Okay. Now, suppose client 1 is send a request, created one thread. Client 2 send a request, created one thread. How many threads are created here? 2 threads, because who want to generate, who wants the alphabets? Now Naresh wants alphabets and Suresh also wants alphabets. For Naresh, your server is created 1 thread. For Suresh, your server is created 1 thread. And then I said here T1 dot start and T2 dot start. So what will happen? For Naresh, it will generate some alphabets and come back to which one? Suresh. For Suresh, it will generate some alphabets, come back to which one? Naresh. And for Naresh, it will generate some alphabets and come back to which one? Suresh. But is it Naresh and Suresh? For this both the people, is it generate the alphabets concurrently or not? Yes. Now Naresh will not wait until execution of what? Suresh. Suresh will not wait until execution of what? Naresh. This both will be executed how? Simultaneously or what? Concurrently. Right? So this is very much useful when you're developing some internet applications, networking applications, servers like that. Now this is so if you see the now you can see. So Naresh, how many alphabets? So first it is given Naresh and then go to Suresh. And for Naresh again generated 1 more alphabet and then Suresh, Naresh and Suresh. Again Naresh, then generated alphabets for which one? Suresh. Again Naresh. So there will be context what here? Switching from one person to what here? Another person. One person means it is called as one thread. So one thread. So one thread. So there will be context switching between one thread and what? Another thread. But every thread is having a name, right? So how can I get a name? So I can get the name by using a function called which one? Or I can say directly self dot what? Name. How you are generating alphabets? Where you writing logic of thread inside which method? Run method. So alpha thread inherit which class here? Thread class. And where you are writing the operation of thread inside which method? Run method. So run method generate all uppercase letters from A to Z. So character of N and self dot name, right? So I created 2 threads, thread 1 and thread 2, and names are given and started. See, every Python program executed within PVM process as a thread. The default thread created by PVM is which thread? Main thread. So where your Python program is executed within PVM process, where your Python program is executed within PVM process, where your Python program is executed within PVM process as one thread. Within PVM process as one thread. Now return the current thread object corresponding to the caller's thread of control. Okay. So suppose this is my program. Who's executing my program? Python virtual machine. But how it will execute? It will create one thread and this thread will call all the statements, all executable statements of my program. Means what is the default thread created by PVM? Main thread. And this main thread is calling which one here? All executable statements written inside your program. And this main thread is create all other threads. Okay, now here if I create a thread, it will create thread 1. If I create another thread, it will create another thread. Now this is thread 1 and this is thread 2. So total how many threads are there? 3 threads are there. What is the default thread? Main thread. And these are user defined threads or not? Yes. This is a event thread. Okay. This is a event thread. And this is what here? Odd thread. This is the event thread and this is which thread here? Odd thread. So every program, and if you want to know what is the current thread, which is in running, so that you can find out by using one method called which one? Current thread. So that will return the thread which is currently in what? Running. So that will return the thread which is currently in running. So that you can get it by using which function? Current thread function of which module? Threading module. So return the current thread object. Return the current thread object corresponding to the caller's thread of control. Okay. But I said no, tomorrow you'll have the class. Tomorrow you'll have the class from 8 to tomorrow you'll have the class from 8 to 11. Okay, 8 to 11. 2 days we'll have the class. Saturday and Sunday. Tomorrow you'll have both offline and online. But Sunday you'll have only online. You have to join with this particular link. So tomorrow class will be 8 to 11. Okay, na? Tomorrow offline and online, but Sunday is only online, right? So we'll stop it here and we'll continue tomorrow, right? Okay. But tomorrow we'll have one special class that is on NumPy pandas, not threading. I'll not tell you threading. Threading will be there on Monday. Okay. But tomorrow, day after tomorrow, we'll have NumPy and pandas, right? So we'll stop it here and tomorrow we'll see this.